So how part of that conversation started was, really looking at some technical detail.
Hmm.
Um, let's take the residential space for example. When we were looking at developing our next generation, so I mentioned the YC600, which was the most advanced microinverter at the time. Its successor is the DS3, which
Yeah.
stands for dual input, single phase, third generation. And in really looking at closely at the details of the industry, um, and with most uh, homes that we were that our installers are looking to put solar on, you had typically about 40 amps of available service on some of these older panels before they would have to upgrade. Now, an upgrade is a expensive cost, can cost you anywhere from $3,000 to $5,000. I had somebody recently that was quoted almost $8,000 on a panel upgrade. So no fun. Okay, let's try to squeeze as much space as we can out of your existing service. So sometimes it's 20, sometimes it's 60, but our average was about 40. And so for whether you're us or Enphase or somebody else, you typically are putting uh, two circuits on there. So basically you're running cable on the roof and you're landing it on a 20 amp breaker. So each one of those would call up a string or a circuit. And the most you can load on a 20 amp breaker due to NEC code is 80%. So you got 16 amps that you can load on that 20 amp breaker. With us, we wanted to be able to maximize that 16 amps. So no matter how much DC that you have on the roof, you could have 10 kilowatts of DC, you could have 20. It doesn't matter how much because you're still only going to get 16 amps through there. Otherwise, your breaker trips, right? Or
Yeah.
if you're doing 17 amps, you have an inspector that's going to look at you got too much load on that circuit. You have to fix it. So they fail your system. So we were looking at putting 5 microinverters on each string. Okay, how many amps does that come out to? And compare that to the 16 that Enphase is doing as an example. They're doing exactly 16 amps with their IQ7, IQ8 because each is a 1 amp unit.
Yeah.
Okay, we wanted to go higher capacity than that because the PV modules kept pushing into the 400s and then 500s. So, okay, how can we accommodate those higher capacity panels? We have to make this more powerful, which means we need to use fewer of them on each circuit. For us, that meant we're going to try 6, 5, and 4 units on each string, which then dictated the output of the inverter. In the case of our DS3, it's 768 watts. And so then you do a AC to DC panel sizing for it,
Yeah.
1.25. And that meant that we could do up to 480 watts on that specific model. Uh, so just I really quickly want to talk about um, the volts and the amps
Um,
because that's
so,
that's
yeah,
the
of
great
course.
equalizer between all inverter companies, right?
Yeah.
So if you have 16 amps on each 20 amp circuit, you multiply that by 240 volts, your output on that circuit AC is 3,840.
Yeah.
So if you have two circuits, that's 7,680 watts. That's us,
Yeah.
that's Enphase, that's anybody. It's
Yeah.
essentially your promise to the homeowner. I'm gonna
Mm.
we're gonna put enough DC on the roof to produce this for your home and uh for the grid. So at a 1.25 AC DC ratio, you're putting about 9,600 to 10K solar on the
Yeah.
roof in terms of PV modules. So we compared the first two models that we had put out, the DS3L and the DS3S, to
Mhm.
the standards in the industry, which was Enphase. So they're 7 plus, 8, 8 plus. And we took a close look at, are we producing, can we produce more energy than their product? Can we pair with higher capacity panels than their product? Can we put fewer units on a string to reduce the amount of equipment that has to go in, the installation time, the labor, and can we still produce that same output? So fewer inverters, fewer PV modules, producing the same output, but it really helped us to show this visually. So we have 10 of our DS3L units can produce that 7,680 watts of output with 20 panels, about 480 watts each. With the IQ7 and IQ8 Plus, that was about 26 of those units and 26 PV modules. So you're looking at maxing out actually with the output on those at 7,500. So in order to actually get to the 7680, you have to use the IQ7 and IQ8 models because, as I said earlier, those microinverters are exactly 1 amp each. So they can actually get exactly 16 amps out of it.
And this is essentially to just match the maximum output.
Yes.
Which is not, we're not even talking about the total kilowatt hours produced out of that system at this point. Just to match the maximum output.
Exactly. So just to match what APsystems had done, you actually have to go with the 7 or the 8 and do 32 of their microinverters, 32 of their PV modules.
Panels. Yeah.
Yeah. So you have 3 times the microinverters, 10 versus 32, and 60% more PV modules.
Yeah.
And so we're like, okay, we have a great opportunity here for solar installers and for homeowners, especially when you have homeowners that are like, I don't have room for 32 PV modules on my roof. It's a smaller home, but I still want to have a great output. And so we're able to help provide a solution for that, because 20 of these PV modules versus 32 of these P modules, there's a big difference. So I'll walk you through that too. So 32 versus 20, the 2,480 watt PV modules, they're larger panels, but they're actually 100 square feet less overall than 32 of, say, the 365 watt PV modules that you might pair there.
Yeah.
And in terms of cost, the 20 larger panels actually cost $500, $2,000 less than the 32 smaller PV modules.
Less wattage you're buying. Yeah.
Right. So this is what we set out to do really with the differentiation kind of over the course of APsystems history is to try to provide, more value. So we want to produce the same energy with less equipment. We want to stay at the forefront of technology. We want to pair with these higher capacity PV modules than competing solutions. We want to install faster. That helps the installers get off the roof and onto another project faster. Give them fewer units to have to stock and then haul up onto the roof, and then fewer turns of the wrench. And we also have a wireless communication technology that we employ. It's because the PLC that most everyone else in the industry uses, it stops dead when it hits an arc fault breaker or GFI outlet in the home. So less headaches with that wireless. Solar installers, thanks to what APsystems has brought to the table, they were able to win bids for the same system energy output, or they could even lower their bid if they have a competing bid that they're bidding against, and they can make more money on that. So they save money on inverters, they save money on install time, they save money on panels, and we are really helping them create a sustainable competitive advantage in their business. And I think that's how we've grown to really step away from just being a multi-module microinverter to really being the installer's microinverter to help them differentiate in a way that we did.